Welcome back to my channel. This is View3ZAG. Today we'll delve into my inaugural radio receiver, meticulously crafted for shortwave exploration. In fact, this very first generation SDR receiver radio commemorates a decade of service within my radio shack. This SDR radio serves solely as a receiver, incapable of transmitting signals, and is housed within a plastic food case. It features a BNC connector for external antenna attached and a micro USB port exclusively for power supply from a PC, eliminating the need of an external power source. A short cable of 3.5mm audio plug connects the radio to the PC sound card. Now, let's explore the circuitry. Components are meticulously soldered onto a hand-etched PCB with some SMD parts like 74HC4052 mux soldered onto deep sockets with extended legs. The compact PCB atop hosts a crystal oscillator constructed around a 28.277 MHz crystal and a few NAND gates, and the oscillator communicates with the mainboard via burr pins. The setup also incorporates a 74HC74D flip-flop and an LM358 dual op-amp. In this video, I'll aim to showcase the receiver's performance, first with a crystal oscillator set at 7 MHz and with an external 14 MHz oscillator constructed using a SI5351 and Arduino. Regarding the radio's operation, it employs quadrature sampling detection or QSD to process the RF signal received from the antenna. This method is achieved through a 90-degree phase shifter constructed using 74HC74D flip-flop and a MUX 74HC4052. Although the HC series ICs typically exhibit high delays and are unsuitable for HF frequencies. The primary reason for the limitation is the necessity for a 4x frequency local oscillator, which the dual flip-flop divides to produce 90-degree phase shifted signals. The resulting I and Q signals derived from the QSD are then fed into a differential op-amps to generate signals compatible with the PC sound card. Here is the current setup with crystal oscillator installed. The SDR is linked to the PC's microphone input and powered by a 5V wall charger. Additionally, an unfed antenna is connected to the SDR. For software, I'll be using SDR Sharp, selecting the source as baseband from the sound card. We need to adjust the audio settings by selecting the correct input and output device from the drop-down menu. I'll maintain the other settings as displayed, and the spectrum's center frequency will hover around 7.070 MHz. Now let's proceed with the tuning.
Propagation also, I am getting you 5 and a 9, do not touch doctor. Have a nice weekend. To comfortable Delta V to down on your good morning, Rangaru from Enava, Rangaru for checking in, not the usual copy. 7 and 8 to 9 is the report. For QSB, very, very stable signal, I can say. Comfortable, 7 to 3 okay, have a nice weekend. Metro, Kilo Tango, Whiskey, good morning. Kotibai from Kulaba, Mumbai,
Very good morning, YouTube. Driver Elliot Juliet, next controller for handle Belgram Lord, taking you to Kilo Tango Whiskey. UTV, yeah, Domigan, 59 plus. Vertical supply, very beautiful modulation, the start of the condition to London. The WSR is around 28 degrees Charlie with almost 73% humidity. Still we are better slightly there. Station time for the station channels that will work in continuation monitoring as carrying as well. very happy days ahead. And India is also trying to check in for possible gas traffic element. Lower traffic, Aries for the left, back to you, V2 driver on your Juliet, to V2 Kilo Tango Whiskey for the morning handle.
जो है वो QSD में कम ज़्यादा होती रहती है। और रही मैंने अभी ऑडियो अपनी वाइड की है, पहले नॉर्वे की हुई थी कॉन्टेस्ट के लिए, तो अभी तो ठीक है। अभी ऑडियो HW00 मैं यही बोलने वाला था, एकदम परफेक्ट 24 कैरेट 16 की तरह V2 ऑस्कर V2 HW। अच्छा ओके रोजर। तो यार और सुनाओ क्या हाल है? और सुनाइए क्या हाल है? कुलदीप से बात हुई क्या? HW00 नहीं, कुलदीप से कोई बात नहीं, ऑल गुड ऑल वेल एंड बेस्ट विशेस टू यू फॉर योर कॉन्टेस्ट विद अ न्यू एंटीना। I hope you get a lot of points.
Now, let's swap out the crystal oscillator with the SI5351 oscillator. I have implemented basic Arduino code to produce a 56.25 MHz output on clock 0. As a result, the center frequency of the spectrum will be around 14.065 MHz. For power supply, I'll be drawing power from the PC while the modules will derive power from the SDR board. Here, I'll be showcasing the capability to decode digital mode signals such as FT8 and FT4. To achieve this, I have utilized a audio virtual cable to extract output from the SDR sharp and feed it into JTDX software, enabling the decoding of digital modes. Let's proceed with tuning. Now, let's take a look at the PSK Reporter to check whether our received packets have been reported. As we can see, the packets have been successfully logged in the PSK Reporter. I hope you found this video helpful. Thanks for watching 73.